So, so sorry, I connected. So hopefully I get a good reception now. The Automate conference, robotics on display. So you got a remote control joystick. A lot of people here for the Wi-Fi. I wasn't getting Wi-Fi, but I was able to connect to the Expo, the Huntington Places Wi-Fi. So hopefully the reception's good. And as I said, last year I came through here twice, through here twice, made the whole rounds, collected paperwork, made the whole rounds, collected paperwork, and it was awesome. I feel like relatively, people are interested in technology. This is where it's at. The 3D printing expo is pretty cool. The automotive conference this week, I was mentioning possibly in relationship to competition from Tesla. So, pardon me. So, really, you have the complete supply chain of everything related to robotics and automation. So automation is not just robotics, but the main thing is robotics. But you have the whole supply chain of the necessary materials for robotic automation, from software, connected devices, electronics, and auxiliary pieces, some connected manufacturing services. So trying to collect my thoughts because I walk around. I just came in. I want to go live right away because I have a busy day today. I'm going to try to come back also on Wednesday if it's possible, just because it's so big. It's basically taking up the whole convention floor. And so just walking around, share my initial thoughts. And Wednesday, I pick up some of the reading material. God willing, come back. I'll have more collected thoughts on what's going on. So just get a little feel of what's going on. People who saw the stream last year, a lot of these are the exact same suppliers. In fact, a lot of them are the exact same places. You can see this thing from the automation. You have the whole gamut of the supply chain. And that includes electrical supplies, computer, software, including machine learning, attachments for the heads of robotics like suction cups, clamps, supply control like SCADA for factory control, there for plants that operate multiple robotics. So you have the PLC circuits, the programmable logic circuits. You also have pneumatic. So just throwing things out there, trying to collect my thoughts. I got nobody watching me. Hopefully the reception's okay. But you can control robotic arms basically one of two ways. And there's probably a few other ways, but two main ways, which is pneumatic, air pressure, and electronics. And the pneumatic would also likely be controlled through the same PLC circuit electronics, but it would just give an electrical signal that would cause air pressure. So you could have just a programmable logic circuit that has electrical impulses programmed in. The electrical impulses will exactly program and tell the robot what to do, how to move, when to move, how much to move. And you don't need an actual computer. You just have a programmable logic circuit that isn't really a computer. It's just a program controller of electrical impulses. And so in a lot of factory controls where they have processes that are repetitive, they simply have PLC circuits with no computer connection. However, most electronics is connected to a computer because, and that could be for various reasons. One, because it's not necessarily repetitive, although like the electric circuit could have a trigger, so you could have an input that says like when this happens, do that. So if you had like a manufacturing process, when a certain aspect of the process is complete, it would send a signal, electric signal, and then that electric signal would be sent to the PLC circuit that would move the robot. So a lot of robotic arms in the automation process operate without computers, if you don't consider the PLC circuit a computer with like a processing unit. However, relatively most processes these days are extremely computerized. Just like the automobile, everything is computerized. And within the central processing, which would also control the electrical signal, so the robotic arm that gets its signals directly from the PLC, because the computer doesn't operate the robot. The computer would send information to the PLC circuit that sends electric signals to the robotic arm. And then the robotic arm moves and does what it's programmed to do. So a lot of these displays are the exact same as last year. A lot of these companies, you probably have a traveling staff that go around to conventions all year and are largely the same people, the same displays. And you see like Funik, one of the larger companies that has all sizes and powers of robotic arms, from precise movement to there you have 2,200 pound payload, and you would have the specifications of exactly the precision that it could move, the axis degrees of freedom. So the computer software
Going down the drain, yeah, for sure.
could have multiple things connected to it. So a lot of you have an input device that big now could be visual detection. So the robotic arm could have an embedded camera. The embedded camera would connect to a computer, and the computer would interpret the data from the embedded camera and from there direct the movement of the robotic arm. And that's a little bit of machine learning, what they call artificial intelligence, to say where it's not exactly programmed the movement is determined by the computer based on a sensor, which could be multiple forms, but usually is an embedded camera. So it could be heat detection, pressure detection, or any form of sensor similar to automotive testing. So you have this is huge. I think they said 30,000 square feet. So yeah, I'm just pacing around, and I'll probably start on the far corner. So I'll scream a little bit more, and then I'll probably start on like a far corner collecting reading material. So the computer software, the control systems, one, if you have multiple robotic arms, the computer system that would have some sort of machine learning with embedded sensors that help direct the process. So there you see like a typical PLC circuit that just sends electrical impulses, and that could connect to a computer that could have multiple devices, input sensors, some sort of program, and all various things. So besides, so that's probably the biggest part of the the conference, the robotic arms and the related computer software, control software, including at this point large amounts of machine learning. Besides for that, you have accessories. And so the accessories are multiple ends. So you have the electronics, the control systems for the electrical feed into the system. So like I mentioned, the PLC boxes, circuits, things like stands. Most often would be the heads. So most robotic arms, you just get a robotic arm, and you could plug in whatever you want into the robotic arm. You'll be graspers, vacuum suction, depending on what you need. There's, most of them are graspers, things like grass planes, and suction cups. Well, in reality, there's hundreds of various things that you could plug into the end of the robotic arm. And so there's companies that make those, and they might have thousands of pieces, various sizes and strengths, and they'll have precision specifications of what they can and can't do. You also have control systems. So if you have multiple factory components, so here you move in that you have suction cups and just moving boxes around that would be automated for an automation control process. And this looks like it's pneumatic. You can hear like the air pressure, the sound coming. That's because it's pneumatic. Although, so it would have to have an oxygen tank or some sort of gas pressure, and so the robotic arm moves from air pressure. Although the air pressure release is caused by an electrical circuit. So I'm not sure if you could see. So they also have the companies that make the gas tank and the systems, the tubing. You have engineering design companies. So if you wanted to automate a process in your factory, you have engineering consultants that basically will do a one-stop shop for you, where you'll tell them what you want to do, and they'll purchase and design and set up the automation process for you. So there's multiple companies, engineering consulting companies that mastermind the whole process. So, say if you're a mom and pop local manufacturer and you want to automate a single process, so let me go back a second and mention training also. So many of these robotic arms are trainable, and so like programming a robotic arm, then you're talking about like Cartesian three-dimensional geometry, and how you have your coordinate system and the exact movements, and there is programming languages. So I mean, essentially it's usually they have what's called degrees of freedom, which in many of these cases is rotational. So as opposed to XYZ, it's a 360 degree rotation. So that would, and it's basically an electric signal that rotates, and they have multiple degrees of freedom. So you might have 6 different possibilities of movement within the robotic arm, and the electric signal or the the gas pressure just moves it a precise amount. And so to program it, so I say it's not like XYZ, it's controlled through a rotational axis. So on any of these robotic arms, you have degrees of freedom, and this has 1, 2, 3, 4, 5, 6. 6 is pretty common, like 6 degrees of freedom for a lot of these is pretty common, but it's rotational. So if you want to get the robotic arm to a certain point, in terms of programming it, you're talking like polar coordinates and rotating various heads to a different amount to get it to a certain amount. So you can see that could be a disaster trying to make those calculations. You're like trigonometry going wild if you're thinking by hand to try to program how do you get the robotic head from one point to another, where you're doing that by rotating multiple pieces a certain number of degrees. So usually that's programmed. But at the end of the day, it's just going to be an electric signal that controls exactly how much the robotic arm rotates. So they have what's called trainability, where instead of programming mathematically through, I don't even know what language, like, so PLC programming is very complicated. It's a very in-demand field to code the PLC circuits that control the robotics. But a lot of them have what's called training, where you could just move the robot the way you want to move it, and then it will repeat the movement. So this is without the machine learning, artificial intelligence. So if you just have one single repetitive movement, or even a complicated process of repetitive movements, you by hand manually train the robot what you want it to do, and then it just repeats the process. So most robotic arms now are trainable in that sense of the repetitive movement based on training. So if you have an automated manufacturing processing line and you have multiple stations, so you can have a robotic arm within a station, or a robotic arm that gets you from one station to the next station. So if it's like automotive manufacturer, like welding, painting, or something like that, there's many different ways, conveyor belts, and it could be manual. You could use a robotic arm to take the piece from one station to the next, and then it performs the task at that station, like within a discrete unit of manufacturing. Manufacturing process is broken into discrete units. So it would start, the first discrete unit of manufacturing process, and then a robotic arm, or maybe multiple robotic arms, would perform the task, and that task for the robotic arm in many cases is the exact same for every unit. So if it does like 1,000 pieces a day or whatever the process, that just does the same thing again and again. And piece comes in to its position, and the robotic arm performs the exact same function. So that would be a cheaper, so here you have a automated process, picking up a piece, sending it, and here it's all just moving. They're not performing any tasks, just multiple moving, and probably these are repetitive tasks that could be trained as opposed to programmed. Programming would be much more complicated. So if you needed an engineering service company that would actually program, or like a CNC, cutting or something like that. So more than the training, you have the machine learning sensor detected movement. So in many things you can't necessarily know, you need a certain amount of precision, and the unit may not be in the exact same place where exactly you want it every single time, or you could have multiple units that's going to pick up a batch or do something, and so you have an embedded camera, an embedded sensor, any type of sensor. It could be camera, laser, heat sensor, and pretty cool there. And the sensor would guide the robot. So the robot, through a machine learning program, would understand the task at hand to some level. Like it would know that it wants a certain piece, it wants to pick it up in a certain way, and it would be, through a computer program, able to read the data from the sensor in a way that would be a form of machine learning, like object recognition, detection, and an intelligent usage of control of the robotic arm to perform a task at hand. So that's pretty new in automation. The technology of embedded sensors and machine learning in robotics has really been around for like a decade, maybe even 20 years at some level. But it's gotten much more advanced and affordable, to the sense where, you know, like $20,000, $40,000, you could buy a robotic arm, you could get licensed, a software contract of a few $1,000s even, that will be some form of artificial intelligence, machine learning, that would be integrated into your robotic arm. And so that's actually the main gist of the automation conference. So you have the companies that make robotic arms, you have the sensors, you have the attachments, you have the engineering design companies, you have the PLC makers, you have certain aspects of the electrical engineering, and then you have computer control systems that could be, you know, multiple levels for one robotic arm to complete factory control, to you know, like SCADA, like Siemens, the, you know, complete computerization, automation of a whole factory plant that could include thousands of robots, all under one universal software. And you know, this is more for manufacturing, but you also have levels of robotics entering the home market, where you could buy robotics for home use. You know, like cleaning now, like, you know, the Sharpie, the vacuum, automation, certain, you know, cooking processes, restaurants, not just manufacture. Although this is focusing mostly on manufacture with, you know, geared towards automotive. You know, like I mentioned, always automotive or bust for manufacturing in general. I mean, there's probably a whole bunch of other companies too, besides that are here. But, you know, you're looking at the whole supply chain, everything you need to automate your process. So here you actually have a Tesla. So I'd say that automation, Tesla is really destroying. So this is Zeiss, a German company. Tesla's really destroying the general automation, the general manufacturing process of the, you know, the big three automotive, like going to the Society of Automotive Engineers, the big three in Detroit, Ford, General Motors, and Chrysler, have to a large extent been swallowed up by the government. They're not as productive. They're not really making advancements. International competition, diplomatic fallout with China. You have a lot of Korean companies here, you notice, but so, you know, we're falling behind, although the current level of automation technology might still be global. I wouldn't even be surprised if Tesla is more dominant here than the big three automotive in terms of the automation process. Like, anyone watch Weekend in Review, have been sharing the Tesla space, and, you know, they have their completely automated factories. You know, let alone for chip making, semiconductors. You know, people think historically like China and cheap labor. However, China is much more advanced in automation. Oh, thank you.
Is this on?
I appreciate it.
Up and over, up and over.
Thank you. Back, so I'll probably wrap up the stream in a few minutes and then start collecting reading materials, and I'll probably come back on Wednesday and stream a little bit more after I've read through some of the material, thought through some of what's going on, have some more insight. It'll take me, probably 2 days to go table by table and collect reading material. So I mean, I don't know, there's maybe 500 different companies here, and here you see EMI, all the various type grippers and robotic arms. And there'll also be maintenance parts, long-term contracts for maintenance of machinery. The supply chain is very complicated. I mean, actually, it's not that complicated. Like, relatively, it's not that complicated. Like, if you want to automate a manufacturing process, the actual know-how to automate a process is extremely complicated. And so like the PLC programming is essentially like the trigonometrical disaster of trying to get a robotic head from one place to another through rotating arms. It's called like a trigonometrical disaster. However, they have computer programs, engineering design companies that would do that for you. In that sense, pretty cool. So I'm gonna walk to the corner and I'm gonna sign off. And I got a busy day today too, in this week, and Shibuya is coming up. But I definitely wanted to come to Automate Conference, see the latest technology, and gather reading material. I'll shake some hands, speak to some people. But I guess I'm more a reading material collector. They also have a conference and networking events. So anyone in the Metro Detroit area that's technologically minded, this is probably the best conference of the year. Most dominant, most tables, international. You could see a smaller amount of Chinese companies, although China's a huge player in the automation process. So I'm going to start at this corner and start gathering reading material. So God bless, signing off. Stupid here. Anyone in Metro Detroit, check it out.